Hello students and welcome to my channel Maths Hub. So today in this video I will talk about the logical connector biconditional operator. So if you haven't watched the previous videos, do watch the previous videos for the other logical connectors: conjunction, disjunction, negation and implication, right? So let us try to understand the biconditional operator here. So in a biconditional operator, suppose P and Q are two propositional statements. Then the biconditional statement is, so you can see here that there is a two-way arrow. P implies both sides. It means P if and only if Q. So biconditional statements are also called as bi-implications, right? So now let us take an example. Let P is you can take the flight and let Q is you buy a ticket. So what will be P by implication Q? You can take the flight if and only if you buy a ticket, right? So here it means both the statements, right? Okay. So now what are the other representations of the biconditional operator? The biconditional operator, sometimes instead of if and only if, we also write as P is necessary and sufficient condition for Q and vice versa. This is one way of telling it. The other way of telling it is if P then Q and conversely. And similarly, we can also write as P if and only if Q. So now why we are calling it as P if and only if Q, right? So let us understand this. P if and only if Q. So now this statement is consisting of two different statements. It's a compound statement, and you can see that the compound statement has been connected with the help of the AND operator. So what are those two sentences? The two sentences are P if Q and similarly Q, wait, P only if Q, right? So the first statement is P if Q and the second statement is P only if Q. So what is the meaning of this? P if Q means if P then Q. That means it is the statement P implies Q. And P only if Q means if Q then P. That means this is the statement Q implies P. And so when we join it with the conjunction operator, what will it become? It will become a both way implication, right? So that is why it is called a by implication, right? Okay. So now let us go through the truth table for biconditional operator. So in a biconditional operator, like the previous ones, P and Q are the input conditions and output is P biconditional Q. So now, very interesting feature is that when they have the same signs, that means if the statements, both the statements are false or both the statements are true, only then the biconditional statement is true. If either of them is false, then it will give you a false answer, right? So that means the biconditional statement is true only when P and Q have the same truth values. That means they both are false or both are true, right? Okay. So now let us understand the truth values with the help of the same example that I quoted on the first slide. So we have the first proposition as you can take the flight and the second proposition is you buy a ticket, right? So now the argument is you can take the flight if and only if you buy a ticket. So let's take the first case, case number one, when the statement P is a false statement and the statement Q is also a false statement. That means you cannot take the flight, right? P is a false statement. That means you cannot take the flight. And Q is also a false statement. That means you cannot buy a ticket. You cannot buy a ticket. So now the argument is that if you take the flight, only if and only if you buy a ticket. So you think that if you cannot take the flight, you cannot buy a ticket, right? So you did not take the flight because you did not buy a ticket. So that is perfectly okay, right? If you don't have a ticket, obviously you cannot take the flight, right? So that is okay. Now let's take case number two. Case number two is when P is a true statement and Q is a false statement. So that means you can take the flight and Q statement is false. So you cannot buy a ticket, right? So will this argument be valid? This argument is not valid because if you can take the flight, then according to the argument, you must have a ticket. So you cannot buy a ticket. So that means this statement will obviously become a false statement, right? Similarly, case number 3, when P is a false statement and Q is a true statement, in that case, you cannot take the flight and you can buy a ticket, right? You cannot take the flight and you buy a ticket. So is this argument a true argument? If you cannot take the flight, you buy a ticket. No use of buying that ticket, right? So that means P by conditional statement Q is again a false statement. And likewise, when we move on to the fourth case is when you have when P is true and Q is also true. That means you can take the flight and you buy a ticket. So that is okay. That is our actual argument. So in that case, by implication, Q is always a true statement, right? So I hope with this example you have understood the truth values of the biconditional operator. So now let's take another example. So a parent is saying a statement to a child that if you don't clean your room, then you can't watch a DVD. So is marking the statement you clean your room with statement proposition variable C and you watch a DVD with the propositional variable D. So the connector that is being used is if then. That means it's an implication, right? And you can see that both the statements are negated. So how will you write this in mathematical statement? It will become negation C implies negation D, right? Okay. So I hope you understood the biconditional operator or by implication. So thank you so much for listening to me. And if you like the video, do hit the like button and do subscribe my channel to get the latest updated video. So thank you so much and have a nice day.